Right, what is good, guys? Let's go over the answers for Special Exam 1, 2024. Okay, so question 1, some complex number stuff. Verify that 3z plus 2i is a factor of f of z. Is my pen thin? Yep. Alright, so for this, we're just going to use some polynomial long division. 3z cubed plus 2iz squared plus 3z plus 2i. 3z plus 2i. So 3z cubed over 3z is 3z squared, just z squared. 3z cubed plus 2i z squared down here. Subtract, we get 0, plus 3z plus 2i, so plus 1. So therefore, f of z is equal to 3z plus 2i z squared plus 1. Therefore, 3z plus 2i is a factor. And so otherwise, solve the equation f of z equals 0. Alright, so that's just this equals 0. So clearly, it's just z is equal to plus or minus I, or negative 2 over 3I. Plot the solutions. Okay, so I is over here. Negative I is over here. And then negative 2/3 I is over here. Alright, question 2. Prove that if x is an odd integer, then 2x squared minus 3x minus 7 is even. So we're going to let x is equal to 2x plus 1, 2k plus 1, where k is a integer. Therefore, 2x squared minus 3x minus 7 is equal to 2k plus 1 squared minus 2k plus 1 minus 7, which is equal to 8k squared plus 8k plus 2 minus 6k minus 3 minus 7, which is 8k squared plus 2k plus 8. And then to show that it's even, we're just going to factor out a 2 here, 4k squared plus k plus 4. And then we're going to just say that this is equal to 2m, where m is equal to 4k squared plus k plus 4, and m is an integer. So therefore, 2x squared minus 3x minus 7 is even, because it is 2 multiplied by an integer. All right, question 3. We have a rational function here, and we need to show, using partial fractions, that a is equal to 1, b is equal to negative 4, and c is equal to 4. All right, so f of x is equal to x squared minus 2x plus 1 over x squared plus 2x plus 1, which is equal to x squared plus 2x plus 1 minus 4x in the numerator, x squared plus 2x plus 1, which is equal to 1 minus 4x over x squared plus 2x plus 1. All right, so that shows that a equals 1. So now to show that b equals negative 4 and c equals 4, we have to use some partial fractions. So let negative 4x over x squared plus 2x plus 1 equal to b over x plus 1 plus c over x plus 1 squared. So this implies that negative 4x is equal to bx plus b plus c, which means that b is equal to negative 4 and b plus c is equal to 0, which means that obviously b equals equal to negative 4 and c is equal to 4. And there we have it. Boom. And boom. The graph of f has one turning point. Find the coordinates of this turning point. All right, so we're going to use this form. So f of x is equal to 1 minus 4 over x plus 1 plus 4 over x plus 1 squared. So the derivative is equal to 4 over x plus 1 squared minus 8 over x plus 1 cubed. And that's equal to 0. We're going to multiply both sides by x plus 1 squared, giving us 4 minus 8 over x plus 1 is equal to 0. So x plus 1 has to equal 2, so x is equal to 1. Substituting 1 back into here, we're just going to get 0, because 1 minus 1. So the turning point is at 1, 0. All right, now you have to sketch the graph. And one thing you should notice here is that the function is equal to x minus 1 over x plus 1 all squared. And because of the squared on the very outside, it means that there are going to be, none of the graph is going to be below the x-axis. So yeah, let's draw in the asymptotes. We have an asymptote at x equals -1 and an asymptote at y equals 1. So y equals 1 and x equals -1, like that. Labeling, turning point here, x equals 0, y-intercept, we're going to get 1. So here, and the graph is probably going to look something like this. Crosses the asymptote, and it approaches it on this side, and then it's just going to go like this over here. So 1, 0, 0, 1. Done. Question 4, consider the vectors 3j plus 3k, blah, blah, blah. Find the angle between A and B. All right, so A, B, cos theta is equal to A dot B. So that's going to be 3 root 2 multiplied by 3 cos theta is equal to, so -3 minus 6, -9. So cos theta is equal to 1 over root 2 negative. That means that theta is equal to 45 degrees. Find all possible values of n such that the dot product of A and C is equal to the magnitude of the cross product of A and C. So we have magnitude of cross product of A and C is equal to A dot C. So A dot C, let's just find that out quickly. That's going to be 6 plus 3, 9. So we need to find when does A, C sine theta equal to 9. All right. So to do this, we're going to find the angle between A and C. So A, C cos theta is equal to 9. And that gives us that 3 root 2 multiplied by the magnitude of C is root n squared plus 5 is equal to 9, which means that theta is equal to arc cos of 3 over square root of 2n squared plus 10. All right, so now we need to find the sine of this. To do that, we're going to create a triangle. If we let this equal to u, then this is the angle u, and this is 3, and this is root 2n squared plus 10. Using Pythagoras, this side is going to be root 2n squared plus 1. Therefore, sine of u, or sine of arc cos, is going to be the square root of, it's going to be opposite over adjacent. Sorry, opposite over hypotenuse. So 3 root 2 times root n squared plus 5 multiplied by sine of theta. So root 2n squared plus 1 over root 2n squared plus 10, and this is equal to 9. And these two cancel, so we get that 3 root 2n squared plus 1 is equal to 9. 2n squared plus 1 is equal to 9. N is equal to 8 onto 4 plus or minus 2. All right. Question 5. Curve of the equation k equals 1 minus x squared for 1 to k on 2 is rotated by the x-axis to form a solid of revolution. Show that k satisfies blah, blah, blah. All right, so pi, integral from 1 to k on 2 of y squared, which is k minus 1 over x squared dx, is equal to 7 pi on 2. Cancel out the pi's. We get that kx plus 1 over x is from k to 2 on to 1 is equal to 7 on 2. So k squared on 2 plus 2 over k plus minus 1 minus k minus 1 is equal to 7 on 2. So let's multiply both sides by 2. We get k squared plus 4 over k minus 2k minus 2 is equal to 7. Then multiply both sides by k, and we get k cubed plus 4 minus 2k squared minus 2k plus is equal to 7k. Then bring everything onto one side, we get that k cubed minus 2k squared minus 9k plus 4 is equal to 0, which is that. Question 6. Brand of weed trimmer involves 3 stages, stage 1, stage 2, and stage 3, which takes W1, W2, W3 hours. So the independent variables assume that they start immediately after each other. Mean and standard deviation and cost at each stage are shown in the table below. Find the mean and variance for the total time to produce one trimmer. So E of W1 plus W2 plus W3. That's going to equal the sum of their means, which is 1 plus 1.5 plus 2, which is 4.5. And then their variance is going to be equal to the sum of their variances. So 0.3 squared plus 0.4 squared plus 0.5 squared. So 0.09 plus 0.16 plus 0.25, which is equal to 0.5. 0.5 hours squared. Find the variance of the total cost to produce one weed trimmer. So variance of total cost, so cost per hour 10, so 10 W1, 10 W1, and then 20 and 15, plus 20 W2 plus 15 W3. So that's going to be 100 var of W1 plus 400 var of W2 plus 225 var of W3. So 100 times 0.09, 400 times 0.16, and 225 times 0.25. So that's going to be, this one's going to be 9. This one's, oh, okay, this one's going to be 64, because 4 times this is 0.64 times 100, yep, 64. And then this one I can't do in my head, so 225 times 25 is going to be 5, 2, 2, 1, 1, 1, 2, 5, 0, 0, 4, 4, 5, 2, 5, 5, 55.25. Adding these together is going to be 73 plus 55.25, which gives 129.25 hours squared. All right, if a single weed trimmer is produced, find the probability that the time spent at stage 2 will be less than the time spent at stage 1. So probability that W2 is less than W1, which means that the probability of W2 minus W1 is less than 0. So E of W2 minus W1 is equal to 1.5 minus 1, which is 0.5, and then the standard deviation is equal to the square root of this squared plus this squared, which is 0.5. 0.5. So this is equal to the probability that z is less than 0 minus 0.5 over 0.5, probability that z is less than -1, which is equal to 1 minus 0.68 as given in the question over 2, which is 0.16. All right, solve the differential equation expressing y as a function of x, given that y is equal to -2, y of 0 is equal to -2. All right, so here, I'm just going to rearrange. So integral of 2y dy is equal to the integral of -x over root x squared plus 1 dx. Left side, we just have y squared. Right side, if we let u equal to this, it's going to be cancel that out. So 1 over 2 root u, so negative root x squared plus 1 plus c. And then when we let y equal to -2 and x equal to 0, we get that 4 is equal to -1 plus c. So c is equal to 5. Therefore, y squared is equal to 5 minus the square root of x squared plus 1. Therefore, y is equal to negative square root of 5 minus root x squared plus 1. Negative because it's a function, so we can't have plus or minus. And then we chose a -1 because y is in the negative values as seen here. All right. Use implicit differentiation to show that dy dx is negative y over x. Okay, so just simple. So differentiating this one first is going to be 2x y squared plus 2yx squared dy dx plus y plus x dy dx is equal to 0. Dy dx is equal to negative, so these two, y plus 2x y squared over these two, x plus 2yx squared. And here I think we can factor out a y, so 1 plus 2xy over x, 1 plus 2xy equal to negative y over x. Find all points on the graph where the slope of the tangent is equal to -1. So that's just a simultaneous equation. This is the first equation, and the second equation is that negative y over x is equal to -1, which means that y is equal to x. So substituting y equals to x in there, we get that x to the power of 4 plus x squared minus 2 equals 0. And this is sort of a hidden quadratic, so we can actually factorize this. Yep, like this. So this must mean that obviously we cancel that one out. That's going to give non-real solutions. X is equal to plus or minus 1. So the points are 1, 1, and -1, -1. All right, a car is traveling along a road. Its position x and velocity v are measured from the position where x equals 0. The velocity v, and so they're related by that, where x is between -15 and 15. A speed detection device is positioned to detect the speed of a car as it passes the position x equals 0. The speed limit on the road is 40 kilometers. The speed detection device will be activated if the car is traveling at 10% or more. Okay, so 10% more than 40 is 44. So more than 44 or equal to 44. Determine with evidence whether the speed detection device will be activated. Okay, so when x is equal to 0, v squared is equal to 1600 plus 672 on pi arc cos of 0, which is, so that's pi on 2, so 1600 plus this times pi on 2 is going to be this divided by 2, 336, 1936. So now we're going to see what 44 squared is. So 16, 17, 0, 16, 1, 17, 6, 3, 1, 9, 1. Okay, so this implies that V is equal to 44. Since V is greater than or equal to 10% more than 40, the speed detection device will be activated. Okay, question B, find the acceleration of the car when x is equal to 12. Give your answer in the form k over pi. Okay, so we need to find the acceleration from this. So v is equal to the square root of 1,600 plus 672 on pi cos of x on 20. All right. So to find this is equal to dx dt. So to find d squared x over dt squared, which is the acceleration, we just need to differentiate this one more time. So d squared x over dt squared. So differentiating this, all right. So it's going to be the derivative of the inside function, which is going to be 672 on pi times negative 672 on pi, over the square root of 400 minus x squared, multiplied by 1 over 2 root 1,600 plus 672 on pi cos x on 20. And then, since we're differentiating with respect to t and there's an x inside, we have to multiply everything by dx dt, which is equal to this. So multiplied by 1,600 plus 672 on pi cos inverse of x on 20. And look at that, these two cancel each other out. So what do we get? We get negative, this divided by 2, 336 on pi root 400 minus x squared. And then when we substitute in x equals 12, we'll get negative 336 on pi 400 minus 12 squared, 400 minus 144, 256, root 256. So negative 336 on 16 pi. 336 divided by 16 is going to be 2, 16, 32, 1, 16, 21. So this gives us an acceleration of negative 21 over pi kilometers per hour, negative 2. Nice. All right, question 10. Let the lines L1 and L2 be defined by these. If the shortest distance between the skew lines is 14 over root 35, find the values of m. Okay, so how do we find the distance between two skew lines? Well, we have to get the dot product of the sorry, let me do this more, explain this a little better. So we have to find the difference between this and this. Let's call that A. And then we have to find the cross product of this and this, and then find the unit vector of that cross product, which we'll call n hat. And then the absolute value of their dot product is equal to the distance. Okay, so let's find the cross product here. So I plus 2j plus k cross product of 2 negative I plus 3j plus 2k is equal to ijk 1, 2, 1, negative 1, 3, 2. All right, so first one is going to be 4 minus 3i, 2 plus negative 3j, 3 plus 2, 5. 5, my pen's not working, 5k. And then the unit vector of this is going to be 25 plus 9 plus 1, 35. 1 over root 35. There we go. All right, and now we find the difference between this and this. So that's going to be I hat plus negative 1 minus m, k hat, yeah, k hat, and this dot producted to I minus 3j plus 5k, and then we can factor out a 1 over root 35, is equal to 14 over root 35. So we can cancel these two. And we get that the dot product of these two vectors is equal to 14. So what does that mean? It means that 1 plus 5 negative 1 minus m is equal to 14. So 1 minus 5m is equal to 14. Negative 4 minus 5m is equal to 14. And because of the absolute value, negative 4 minus 5m either equals 14 or negative 4 minus 5m is equal to negative 14. So first one, we get that m is equal to negative 18 on 5. And second one, we get that m is equal to 2, I think. 10, yeah, 2. So m equals to 2, negative 18 on 5. And there we have it, guys. Those are the answers for the Special Exam 1. I will upload the Exam 2 as well tomorrow when it comes out. But yeah, thank you so much for watching. I'll see you later. Ciao.